cubed, anything with an a cubed is considered a term. And you'll notice on the right here, I circled the addition symbol. The operator always goes with the term, like it always goes to the right. That plus goes to the right. We'll see that the negatives go to the right. So that's 10 and 3, that's 13, a to the power of 3. Is that okay? Is that clear?
Yeah.
Now the next one you're going to see me circle is minus 4a squared minus 4a squared. Okay, and the negative goes with the term on the right. So you have to treat it, off to the side. Here's minus 4a squared minus 4a squared. Can you tell me the result of combining those?
Minus 8a squared.
Perfect. Very good. And then, last one here, plus 5a plus 7a.
8a.
5 and 7.
12a.
12a.
Sorry.
Yeah.
I don't know how I got 8 in my head.
That's okay. The stuff that you told me, being able to combine like terms is key. So that's the good stuff there. All right. So this is considered in standard form, and the reason is it is in descending order. Okay, the highest degree power is 3, second highest degree power is 2, and then there's a 1 there, and so on. So we would almost need to see one that's out of order for you to know this, but you always start with the highest degree ones first. The degree is 3. Okay, and the reason is that's the highest exponent. And then the last thing you're asked for is the number of terms.
3.
3. Yeah. You're just counting there. Okay, so not bad, right? Like that's pretty straightforward. The more difficult problems occur when you have this subtraction operator. Did you get all this down? Sorry, I don't mean to move so fast.
Yeah, I got it.
Got it. Great. Okay. Okay, so number 2 we'll look at next. Okay, so this one has a negative. Okay, and this negative applies to both terms inside parentheses. So a couple of ways to think about it. Option 1 is you can think of it as multiplication by -1. Option 2 is to think of it as changing the signs. And what I mean by that is 2x squared is positive, so now it's negative. 9x is negative, so the negative makes it a positive. Doesn't matter to me, doesn't matter to your teacher. You have to decide, which way you want to think about it. Okay. Multiplication by -1, that means you're literally writing -1 times 2x squared, -1 times minus 9x. When you do option 1, you always put a plus in between. So do either of those resonate with you? Either of those familiar?
Kind of.
Really. Did either of them stand out to you? Like, oh, Matthew, I like number 1, or I like the second option?
Changing the signs.
Okay, let's do that. All right. I'll just reframe the question here in case you want to look at that later. Okay, so like I said, you just change the side. So 2x squared is positive. There's really a plus there, so we make it negative. The minus 9x is really negative, so we make it positive. Okay, and that's the change of the signs.
Oh, okay.
It's like the lights on or the lights off. Lights on, lights off. One or the other.
Yeah.
On the left here, what is out in front here of this parentheses? Any idea? It's okay if you
like positive.
So there's a plus. There's a plus or a 1, but what there is not is there's not a negative and there's not really a number. 1 doesn't really count in this case. So you can drop the parentheses. You can just straight bring those down. So most of the time in these problems, the first one does not have a negative in front. So you just bring those terms down. All right. So are you caught up to this line here with me?
Yeah.
Okay. what two terms can we combine next?
4x and 4x to the
Power of 2?
power of 2 and minus 2x to the power of 2.
Good. Said really well there. So 4x squared, if you want, minus 2x squared, what does that become?
2x squared.
Yep, or 2x to the power of 2. Good. And you can combine the other two terms here. Can you tell me what they become?
2x.
2x, good. And I would encourage you to use colored pencils or pens or highlighters, whatever you like to be able to see this. I mean, I think the colors are helpful here. So this is in standard form. Okay, so we got the check on that. What is the degree of this one?
Second.
Yep. Another way I could ask you is, what is the highest exponent? What is the biggest exponent that you see above an x? And you would say 2. You'd say 2. How many terms?
2.
2. Good. Any questions about this one?
No.
Okay, let's go to number 4. It's really similar, but we'll work it out together. So I'm sorry, did you get all this down, or do you need a moment for that?
I got it.
Okay. All right. So just like in the previous problem, you got this minus out in front, and it always goes to the right. It always goes to the right. It's never to the left. Like we always have put adjectives before our nouns. That's just the way this goes. So you said before you like the idea of changing the signs. Okay. So that's 6x squared. Is that positive or negative?
That's it becomes negative.
Yeah, said really well. It becomes negative. It kind of is already, positive inside there. 7 is positive, so it becomes negative. And then you bring the other stuff down. Now it is okay. It is totally okay that 6x squared and minus 6x squared cancel. Like that does happen. And you'll even see crossing that out when it does. So what's left over is the plus 9 and the minus 7 just becomes 2. And that's okay, just the way it is. Now this one's a little bit harder when I ask you the degree. So it's probably good that we're doing this. Let's do the easier one first. How many terms does this have when it's all done?
1.
1. Okay. So here's the standard form of a polynomial. It's like ax to the n plus bx to the n minus 1 plus cx to the n minus 2 and so on. And you're like, well, that doesn't really help me. And I'm like, you're right. So here's though what happens. Like, let's just say it's an x squared. It's ax squared plus bx plus c. This x is to the power of 1, and the c is really times x to the power of 0. We just don't write it. Like, this is never written, but there's really an x to the power of 0 here, but it's not written. And if you're wondering, well, why are you? It's because that tells you the degree. The degree is 0. So whenever you have a constant, which is the case here, you have to somehow remember, oh yeah, it's degree 0. And if that doesn't make any sense, sometimes you just got to accept it for the time being until
Okay.
All right. I'd like you to try number 6 on your own.
Right.
And when I have you do a problem on your own, I want you to ask questions if you have any. But what I'm looking for first is just like that first box there. I'm looking for the standard form, like whatever goes in that box. So work that out, or if you have questions, please ask.
I got 9x to the 9x to the fourth
Good,
plus 7x minus 10.
perfect, yeah. Okay, and what's the degree of this one?
4,
Very good, and the number of terms?
3.
Yes. Okay, so that's great. I think you totally understand. You might even be able to do like 7 and 8 while I'm talking. They're pretty straightforward. We're gonna look at 5 next, though. It's got a little twist to it, a little wrinkle that makes it a little bit different than the others. So let me know when you're ready for us to talk about number 5.
All right. I got it down.
Fantastic. Okay. So a like term has to have the same exponents. Okay. So like we've already looked at something like 5x plus 7x. Those are like terms. Or 6x squared plus 3x squared. Those are like terms. But it's also the case that if you have like 3xy plus 6xy, these are also like terms because they have the same variable to the same power in both. So in this problem that you're given, these are both like terms. They have the same power 2, x to the power of 2, and y to the power of 1, but they have to be exactly the same. Okay, so these are combinable because it's an x squared and an x squared. It's a y and a y. Okay, so the result is 12 x squared y. There's 12 of them. There's 5 here, 7 here.
Makes sense.
Yeah. Okay, but now here's what will not make sense is when we talk about the degree. So math is full of exceptions. It's probably one of the reasons most people are frustrated with math. And I'm with you. I don't like the exceptions because it's like, well, when do I know to use them? So this one's degree is 3. And the reason it's 3 is you take the power from the x and you take the power from the y and you add it together. Maybe you like that, maybe you don't. But let me go up and show you why this is always true, by the way. It's kind of hidden from you. Let's look back at the previous problem here. So you said the degree was 4. Let's just say it was 9x to the 4th and y to the power of 0. What is 4 plus 0?
4.
Still 4. So it still works. It's just we don't write y to the power of 0. But you can imagine if there were like a y to the 1 here, it would change the degree. So the rule always works. You always look for the highest degree exponent, but when there's 2 exponents, you have to add them together. So like a little twist, I don't like it, but that is the nature of these problems. You might get one like that on the test quiz. And this only has one term. It's just the 12x squared y. Okay, I'm going to suggest you do 7 and 8 on your own later on, or if we have time, we can always come back and we go to 9. Does that work for you?
Yeah.
You can always tell me that. You can say, you know, Matthew, I really want to work on the ones, everything in order. This is totally your time. Whatever you want us to work on, happy to accommodate.
No, let's do 9.
Okay, so number 9, story problem. These aren't usually, most students are like, I don't really like these. Do you like to read? Just curious. Do you like to read books?
Yeah.
Great. Yeah, reading's awesome. Lots of good books out there. Not necessarily in math though. All right, a triangle has three sides of the following lengths. It's 2x plus 1 units. So that's a side. They're saying that's a side. 3x plus 5 units, that's a side. And 4x minus 1 units, that's a side. Okay, so it's always good to draw a picture. You probably remember that from a previous class, or back in the math, back in the day when you're doing a different math class. But when you write it, it's good to show the three sides. And the triangle you draw is arbitrary. It could be anything you want. But they're asking for, they're asking for the perimeter. Any idea what the perimeter means or what that refers to in this problem?
Pretty sure it's all this the
Yeah,
sides added up.
right. So I can, like, to me, the perimeter is, it's a walk around. You say, okay, I'm starting at one place, I'm gonna walk there, I'm gonna walk there, and I get back where I started. Okay. So in this problem, it would be 2x plus 1, the order doesn't matter, plus 3x plus 5, plus 4x minus 1. Okay. Could you simplify this expression for us and let me know what you come up with?
Sure. Yeah, 9x plus 5.
Yes. Very good. All right, so we'll move on to number 10. All right, so this one says a rectangle. So it's good to draw a rectangle. I don't know if this is the right one, but it really doesn't matter. It just, the picture just helps to kind of separate it from the rest of the words there. Side lengths of 4x plus 2 and 5x plus 3. So I'll just call this one 4x plus 2 and 5x plus 3. You will learn next year in geometry that the opposite sides of a rectangle are congruent. You probably already know that, but you'll learn why that is the case. So it's always a good idea to just write those other sides in. And same thing here. They want you to find the perimeter. So it's a walk all the way around. You've just got to add up all of these expressions. Okay. So why don't you work that out and let me know what you come up with.
Okay. $18x plus 10.
Yes. Very good. Okay, so pretty much done with that. We can move on to the post review, if that's okay with you.
Yeah.
All right. So what is a post review? What is the to me that sounds like you've already had the test and now it's the after the test.
So I think on last test, people did so bad on it. Like the average was so bad that they do the review again because they're gonna redo the test this week.
I see. So this, you already had test number 2, and it's like, hey, these are the things on the test that most people didn't understand. So we're gonna do some questions on them. Is that right?
Yeah.
Okay. All right, cool. Now, do you have math 7th period? Is that like the end of the day every day?
Yeah.
Boy, how is that? Is that like a torture sentence? I mean, is that awful or is it okay?
Mm,
It's okay. You don't have to answer that. I'm just, sometimes students say, boy, I'd like to get the math out of the way early, or boy, first period, it's really tough, so don't worry about that. Okay, so the first one here, you did write the correct answer. It is 1 over 125, but my question to you is, do you understand why it is 1 over 125?
It's hard to explain, but like when it's minus becomes a fraction.
Yes. So it's
So
really like this 1/5 to the power of 3.
yeah.
Yeah. So what it really is, what I'll just go off to the side here. So here's what's really happening. 5 is really 5 over 1. Okay. And the negative is what causes the fraction to flip. And then the 3 actually applies to both the top and the bottom, but 1 to the power of 3 is always 1. So that's why you only see it appear on the bottom. And if you think of it the way I just showed you here, there's some more difficult problems where that might make a difference. But really good there. 4 is also correct. Nice job on 4. So let's look at number 2 and start out here. Number 2. Okay. So this is it's really like two problems in one. It's really like this a to the 8th over a cubed. And then you're looking at this b to the 3rd over b to the 9th. Okay. And do you have any idea how to proceed from here? It's okay if
I
you
know
don't.
that with um like a to the 6th or a to the 8th and a to the 3rd, it does like a subtraction thing. So
Yes,
it would be
really good. So it's written this way, but I think the words are more powerful. If the bases are the same, if the bases are the same, in this case the base is a, and you're dividing, you subtract the exponents. And it's always top minus bottom though. Okay, so in your case, it would be a to the 8th over a cubed is a to the 8 minus 3, which is a to the 5th power. So this red one becomes a to the 5th.
yeah.
Okay. Now for the B, a little more, a little bit, this is where it's, a little bit different, a little bit harder, because it's not that the subtraction is hard. It's that, okay, 3 minus 9 is -6. Now what do I do with that? Well, when you apply this rule, notice this number is sort of free floating, but it's really in the numerator. The answer to this is always in the numerator. Whether it's positive or negative, it's always in the numerator. Is that okay? Is that clear?
Yeah.
Okay. And now we still have more to do, but this is a good start. All right. Now, you just kind of answered what to do with this negative exponent in the previous problem, but here's why. When they say to simplify in a problem like this, it's encoded that they mean no negative exponents. Okay, so you cannot leave the negative exponent, even though this is correct. Even though this is correct, it's like it can't be written this way. So you write it as 1 over b to the 6th. And the a to the 5th is really a to the 5th over 1. All right, so now you can multiply the tops and multiply the bottoms. So that becomes a to the 5th over b to the 6th.
Makes sense.
I like hearing that. That's good. Okay, we're gonna move on to number 3. It would be awesome if we had like time to do another example problem. So if you ever like, hey Matthew, I really need another example of that, or I'd like to try one on my own, I can always provide one like that, but we can just keep running through this for now. All right. Any idea how to proceed with a problem like this?
I think that the parenthesis in between the like the over 4 or not the to the power of 4 and to the power of 2 is I think it, if I remember correctly, it means to multiply the numbers.
Yeah, it does. So that's good. I'm gonna come off to the right here and just draw a we're just looking at another problem here for a moment. Can you tell me what 6 to the power of 2 is?
36.
36. And do you agree that 6 is really 2 times 3?
Yes.
So what the rule says is you actually take the 2 and apply it to both of these exponents, and you multiply, like you said. So it's 2 to the power of 2 times 3 to the power of 2. Okay, now what is 2 to the power of 2?
4.
And what's 3 to the power of 2?
9.
Very good. 4 times 9 is 36, which we expect. So sometimes it's good to, not that you would ever want to do it this way, but it's good to just remind yourself, well, what exactly is going on? The property says if you have a times b to the power of n, each of these gets the exponent. Okay, so you got to give this 2 to that 4 and the 1 there. Okay, so it's really 3 squared x to the 8th power. And it's often forgotten to give it out to the first number. It's usually like, oh yeah, I forgot, kind of thing.
It makes sense.
Okay, now this is not done. It's close. You can simplify the 3 to the power of 2. What does that become?
9.
9. So this is 9x to the 8th. All right, so let's go to 7 and 8. We'll come back to 5 and 6. The reason I want to do those is they're actually just like the ones we did on Sunday. So this should be a little bit clearer to you. Meaning like seeing it a second time, third time, you're like, oh yeah, it doesn't look so bad. Okay, so geometric sequence, and then they want you to write an explicit formula. So the formula is, I'll write it here. It's the first term times this thing called r to the n minus 1 power. So that a1, you saw that on Sunday. A1 is the first term, which in this problem is the value of 4. Do you remember how we found r in this and when we did problems like this?
Was it's the how do I say this? Like the rate.
So I'm trying to help you out here on the right. It's the ratio between terms, which may not mean much at this point, but ratio means division. It's like 12 divided by 4. It's the next divided by the previous, and then it's 36 over 12. And what you're hoping is that these are the same. So is 12 divided by 4 the same as 36 divided by 12?
Yes.
Yes. And what is it? What is that? What does that reduce to?
3.
Good. So your r is actually 3. Okay, so we're going to write our formula now. It's 4 parentheses 3 to the n minus 1 formula. And so in this formula, you have to find 2 things. You have to find the a1, which you found, was just given. And then sometimes you have to calculate r. In this case, we did that over here. Does that you remember us doing that on Sunday?
Yeah.
Okay. It's okay if you don't, or if you're like, yeah, I remember doing it, but it doesn't make any sense. That, that's fine. Just sometimes it's good to be like, for me to know if we need to go over it again or not.
All right.
Nice. Okay, ready to go on to number 8?
Yeah.
All right. Okay, so this one says the first term of a geometric sequence is 3 and the common ratio is 5. So they're giving you the values of the formula. What are they giving you? What is 3 and what is 5 in this problem?
The R is 5 and the first term is 3.
Yes, A1, A subscript 1 or A1 is 3. Good. Now, we didn't do this in the other problem, but you're really supposed to write an A subscript N there. Not super important, but it would be complete with that in there. This time they want the sixth term. So if n equals 1, that's the first term. N equals 2 is the second term, and so on. So what is the value of n for the sixth term? Is my question unclear, or want me to restate it?
I'm just kind of calculating.
Oh, you're doing it already. Awesome. I like that. Yeah, 5 to the power of 5 is quite large. It's probably beyond what you would be expected to know for like a standardized test, but so you should get 3 times 3,125. So final answer should be 9,375.
Yeah. I got it.
Got it down. All right, let's go back. We're going to look at 5 and 6, but I'm just going to give you a little bit of information on these before we start. There are 2 types of things that you have to know. You have to know what growth means and what decay means. And I don't mean in like the literal word sense. I mean in the math formula sense. So growth is 1 plus R and decay is 1 minus R. And this is good to kind of have down in your notes. This would clear up a lot of things. If the problem says that the thing grows, if it says that it grows at, for example, 40% per year growth, that means that R is 0.4. Okay, so the reason that's important is that in the formula, and they kind of don't tell you this very clearly, but it's 1 plus the growth rate, 1 plus 0.4. And if it were like a decay problem, let's say it's like, oh, it goes down 8% per year. That means your R is 0.08, but because it's going down, because it's decay, you go 1 minus R. Right, and it'll make more sense when we look at a couple of problems here. The other thing to notice is that the 1 plus R is always bigger than 1, and the 1 minus R is always less than 1. And you're looking, when you look at this problem 5, you're looking at the number in parentheses. So my question to you is that number in parentheses bigger than 1 or less than 1?
Bigger than 1.
So this is growth. This is growth. And since it's growth, we can write 1 plus R equals 1.4. Because of these are actually called factors up here. If you need to know that quite yet, but since it's growth, it's 1 plus R equals 1.4. If you subtract 1 from both sides, R is 0.4. And this is what they're asking for. The percent change. But you have to say some words. You have to say, oh, this means 40%. And then you also have to say whether it's growth or decay. You have to say that it's growing at 40%. And it's growing because of the factor is bigger than 1.
Okay.
Now, I don't expect you to fully understand that, but if we have more time in a future lesson, we can certainly go back. We'll do number 6 now. Kind of the same scenario here. That number in parentheses, is it bigger than 1 or less than 1?
Less than 1.
Yeah, so that's decay. It's decay if that number is less than 1. You look in the previous problem, oh, it was bigger than 1, it was growth. That's what you're looking for. So then you can write this form. You can say, oh yeah, it's 1 minus r equals 0.68.
Okay.
Because you're always looking for the rate. Like they generally want to know, like, what's the rate? What's it growing at? What's it decaying at? So to solve this, you subtract 0.68 from both sides. And that results in 0.32 minus r equals 0. Add r to both sides. So r equals 0.32. And that's 32%. 0.32 is 32%, but you have to say whether it's growth or decay. And in this case, it's decay. It's dying, it's not growing.
Okay.
All right, let's do number 11 next, because it's another one of these growth and decay things. So maybe it'll make more sense doing a couple more of these examples. Did you get all this down? Do you have any questions on this?
I got it all down.
Oh, done. Okay. So yeah, so we're going to go to the back side of the paper. We're going to go to 11. Another story problem. Okay, the museum has 1,200 members, and the number of members is increasing. Increasing, that means growth, at a rate of 3% per year. So since it's growth, you have to say, oh yeah, that's 1 plus r. Well, your r is 3%. It tells you that, says the rate is 3%, but you don't work with percentages. You convert that to decimals. What is 3%? My question to you is, what is 3% as a decimal?
0.03.
Good. So this is 1 plus 0.03, which is 1.03. And that's the formula that goes, or that's the number that goes in the formula. So you probably saw the PAT formula. Maybe you saw PERT, but we'll go with PAT. That's the value of A. So 1.03. P, and maybe use a different value. That's the initial amount. And they give that to you. Say, oh yeah, the initial amount is 1,200. So you have to find P and you have to find A in these problems. And sometimes they're given like they are here. Sometimes you have to do a little bit to figure them out. But that's not what it is. It does say to write an exponential growth function. Like, so we've done that. Yay, we got that part done. But now you have to find part B here, find the number of members in 8 years. So that means that T is equal to 8. So that's 1,200, 1.03 to the power of 8. Now, do you have a scientific calculator available today?
Oh man, I forgot to.
That's okay. So here's what I'm gonna encourage you to use here. I'm gonna throw this in the chat. If you ever don't have one, Desmos Scientific is great for that. I'll just drop a snip in of what I did here. It's very intuitive to use. It's very modern. It's more like what we use on our phones. So I just did that here for you, so you can see. Basically, just type it in, just like the way you have it written here, and you can see the answer is 1,520. Right. Let me know when you get all that down. We'll have to quickly talk about 12.
All right.
Got it. Okay. Okay, number 12, it says the cost of a flat screen TV is 750 and decreases. So that's decay at a rate of 7% per year. So when it's decay, I'm going a little fast here, but it's 1 minus R. Your R is 0.07 from the 7%. So it's 1 minus 0.07, it becomes 0.93. Your initial value is 750 to the power of T. Right, so you go to a calculator again and get these numbers in there. And now it wants it after 4 years. And you find that it's about $561 roughly.